What's going on, everybody? It's your boy JT Knows Things, and we are back in the Crypto Den. Today, we're actually going to switch gears a little bit and go to the crypto classroom. All right, at my partner's place, Steve Wolterman. We are meeting every week and filming a podcast. So we're going to publish the audio version on every platform: Spotify, Apple Podcasts, you name it. Crypto Classroom will be there. Your boy will be explaining in long form all the fundamentals that have made me successful in the space and teaching my partner Steve along the way as to what the hell is crypto and what are we doing with it. This is the episode. I just wanted to pop right in and introduce it. It's very exciting. I hope you learn something valuable. At the bare minimum, you become a better investor today than you were yesterday. Thank you so much for your love and support, tuning in, watching this, listening to it. Whatever you do with it, may it bring you a different level of sophistication. Peace and love, guys. Until next time. Welcome, everyone, to the first episode of Crypto Classroom. I am Jake Tullis. I am the fund manager of Leading Edge Capital. And I first got started into crypto in 2017 when I was really frustrated with the SWIFT system and wiring money internationally. And I heard about this thing called XRP and never really looked back since. And with me, I have my co-host, Steve.
Hi, Steve Wolterman. I'm actually an attorney, not a crypto buff, but an attorney at a small law firm. Got a background in tax, do general business law, do a lot of real estate 1031 tax deferred exchanges. You might ask, why am I here? One of the kind of purpose of this podcast, I met Jake about a year ago, and over a course of a few conversations, was just captivated with his knowledge about crypto and Web3, and just realized how little I knew about it. I think well enough educated person, see a lot, sophisticated things in my practice, but just didn't understand anything about crypto. And, here we are. I think that we have a chance in this podcast. There's probably a lot of people out there like me, middle-aged guys, women who, feel like they don't want to miss out and they want to understand, but, what questions to ask. So we'll give that a shot here. So.
Awesome. So what's on the docket today?
Well, being our first podcast, I thought we would start with some real basic stuff. As we've talked kind of early when you were explaining things to me, there's this concept that we have, Web 2 and we're moving into Web 3. And, maybe you could comment a little bit on what's the single biggest, are there some real core technological advances, for instance, like the blockchain technology, when everybody hears when we're talking about crypto, is that one of the biggest, advancements and developments, and maybe kind of take us from a real high view as we kind of ease into this.
Yeah, I like that. So I think first, if we were going to start trying to understand what a blockchain is, I think we need to understand what the traditional idea of a network is, right? So Web 2 to Web 3 it's just as important to understand where we're going, where we're at today versus like where we've been the past 50, 60 years. So I think to start, I'm going to explain what, the first iteration really is. And it's what we're all accustomed to. We probably haven't put a lot of thought into it. So
first iteration being if there's Web 3 we're moving into from Web 2, the 90s, 2000s, we're talking Web 1.
Exactly, yeah. Actually, yeah, we could go all the way back to Web 1. Web 1 was really just this exchange of information. It would have been like as soon as the internet became commercially available, that's what .com means. Some people don't know that. .com literally means commercial use of the internet, and the internet is a public service that the government worked on from 1954 until 1989. They started contracting private entities like Oracle, and it would have been IBM back in the day to do kind of Department of Defense worked to build out this thing called ARPANET, which is the very first iteration of the internet. Um, Once ARPANET was kind of figured out, and we created these things called databases and servers and all that stuff. 1989 came around. The very first web point 1.0, sorry, it's plural, is more, was kind of commercially available, and all we really did with it was put text out there, static sites. Like if you can think back to the early 90s, all it was websites with basic information. And that's what the internet was until the advent of social media. That is Web 2. When the internet transitioned from just I would call it a town square of information into a social paradigm where if you don't use the internet in your day-to-day life, you're at a disadvantage now because you don't have that social notoriety, which can be monetized and everything else. Marketing is a lot different. That's all Web 2. And then Web 3 talks about the integration of value on the internet now. I know that's like a very complex thing that we'll get into, but that would be the third transition. So now we went from information to our kind of social place in the world, and now it's also going to be where we store all of our value because it's just, I guess, the natural order of things.
Is that something, I know I've had people ask, do you have to go somewhere else online to access Web3? Does it exist like in a different,
Yeah, that's a great question. So no, the URLs are the same as a website. You wouldn't even know in the future when this stuff is fully adopted. You wouldn't even know the difference. You wouldn't know the difference between online and on chain. The experience would be seamless. We're not there yet. A lot of development needs to happen in the space for us to get there, but that would be the ultimate kind of experience for a user in the future. Absolutely. A big part of what separates Web 2 to Web 3 and how we get value on the internet is definitely understanding blockchain. So you have in Web 1 and Web 2, you basically have this idea of a network. A network is just a collective group of participants. It could be a computer, it could be, humans, doesn't particularly matter. A network is just as it describes. It's a net of different things working together and communicating. In the sense of blockchain, it's specific to computers. And in this network, traditionally in Web 2, we had the development of these big companies, these massive conglomerates like Meta and Twitter, Facebook, you get it. And Amazon, like that's called a monolithic structure where it's just a centralized entity that owns the consuming application or just like the thing you interact with, Amazon.com, for example. And then they own the servers that all of your inputs get stored into. So when you click buy or you create a shopping list on Amazon, whatever it is, they store all that information. They own it. It's tied to your email account that they own it.
So when I log on to Amazon into my account, I'm essentially entering an Amazon network. It's controlled by them. They have all the information. They keep all the information about my habits, and that's a monolithic.
Yeah, that's exactly it, Steve. Okay. So they own all of it. They own them servers. They then take it back to more servers, and there's usually a large chain of computers in this kind of monolithic structure, just a vertical slice of a network. And there's a few inherent issues that we've just accepted with that structure in modern day. One being, we just accept the fact that if you violate terms of service, let's say, it is totally in their right to get rid of your account, all of your order history, and block you from ever using their service again because it is their private property. In Web 2, we accept that. You can see that being more and more controversial over time. People getting cancel culture. That's a big social movement we're going through right now, and it's purely because of this monolithic structure.
In Web3, everything's decentralized and not one individual has a say over your user account, your credentials, or anything else. Um, to understand how it works, we got to get there though. So in this monolithic structure in Web 2, they own the entire stack, meaning the consuming app or the website, the servers, they own all the fields you give them, all the data you give them, they own everything. That's called a stack and they own it all. In Web3, what we've transitioned to is a really cool space where there's financial incentive to participate in the network that keeps all the bad actors at bay, which would allow us to basically break down this monolithic structure and create a distributed network, which theoretically, since the founding of computer science, has been the ideal state of technology. You can do a lot more with distributed computing platforms than you can with monolithic structures. Uh, Overall, though, what allows us to do this is it's threefold really. You have security, so that's encryption. For the people listening, encryption is a really smart, fancy way to say passwords and just security in general. If you think of encryption, just think of you got to type in your 16-character password to log into your email.
Yeah.
And then it's also that financial incentive part. So just to give you guys an example here, Bitcoin. In Bitcoin, for you to participate in the network, you need to own Bitcoin. And your financial success related to that Bitcoin holding is directly attached to your behavior on that network. So if you buy some Bitcoin, then you buy a miner, let's say, and that's just a computer on the network for now. We can get into what mining is in a second, but let's just envision just a computer and you start mining it and you try to do something poor. You try to approve a transaction that is not credible, or you try to be a bad actor. One, you need to get consensus from all these other computers as well. So unless you own 51% of every computer on that network, which by the way is in the millions, so it's not likely.
If that's a monolithic structure, what else is there? Where are we headed?
Got it. So the next iteration of these network structures would be a distributed computing platform or a decentralized network. Another word for monolithic structure could be centralized structure. They're pretty much synonymous. The next iteration, distributed or decentralized, just means instead of one entity or one individual owning the entire stack or the consuming application, the servers, and the data, we have a community of participants owning the stack and everyone having their own kind of role in that network.
Okay. So when you say that, back to Amazon and this monolithic structure, I also see that as Jeff Bezos, at top.
Yeah.
You know, owns the majority of Amazon. Can you give us an example? And I promise we will get to blockchain, but an example of a company right now, or I understand we're not always considering companies or a project or an asset. How is that owned when it's not monolithic, when it's not centralized? And when you're saying distributed, I mean we're talking all of these people and network together, peer to peer.
Yes.
So not logging on to Amazon's network, but
Yeah, absolutely. So it's interesting. So to solve for that question, there's a lot of different projects and they've all figured out. An example of a distributed network would be Bitcoin. Another example would be Ethereum, and then there's quite a lot. And each network kind of has went around that problem of how do we avoid bad actors, and how do we incentivize good behavior? And there's a lot of different ways that these projects have solved those issues. Primarily, the chief or the number one thing that keeps people from behaving poorly, because you got to remember, this is peer to peer and it's anonymous. So, I mean, I'm talking some random person in Guatemala could be contributing just as much, if not more, than someone in America. And you don't know who that is. They're just random numbers represented by a wallet. So the biggest way we avoid this is having your net worth or your financial stability tied directly to your participation in the network. A good example would be like if you put $1,000, let's say, into your kid going to school, but then you could get fined every time you showed up with an attitude to a parent teacher conference, let's say, right? You're probably going to show up on your best behavior if the fine was substantial. In Ethereum, that happens all the same. If you behave poorly as a validator, you could get your entire ether wiped by the network. And the really cool thing about it is there's no opinions there. It's all enforced by code.
So I feel like we will need to get into, the role of a validator. Like I myself, I own some ETH. I'm certainly not validating anything, wouldn't even know where to begin. I'm not sure what my participation is. I own Bitcoin. I don't, am I participating in any sense? I just own some on an exchange and, I'm hoping for the appreciation of it.
Well, when you picked up that Bitcoin, what did you do?
I put US currency, deposit that into Coinbase in this case, and then, went and bought when I thought the price was good.
Yeah.
And continue to accumulate, and I just hold it.
So when you exchanged your fiat, that dirty US dollar, for some Bitcoin, you locked that value on that network, increasing its market capitalization and making it a more credible network in the sense because it is securing more value. And that's really the theme behind Web 2 and Web 3 with this moving value to the internet. The internet of value is the third iteration. So you're participating from that standpoint, but there are different levels of participation. If you were to decide to get an ASIC, is what it's called, but it's basically just a computer that you would use for your video games or something, and decide to start mining Bitcoin, you would play a completely different role in that network.
Sure. Well, before we go down too many rabbit holes, we said we wanted to talk about blockchain. What is blockchain? Why does it excite someone like you? And why should we be looking forward to this in the future?
Blockchain, I mean, that's a great question. I mean, blockchain is this, it's almost like magic in a sense. If you could imagine, if I were to pitch you back in, let's say 2009, that in 14 years, you're going to be able to trust a complete stranger halfway across the world to approve, a transaction that you're making with, let's just say your buddies out at a bar, and you are going to do it quicker than Venmo, or Venmo didn't even exist back then. You're basically going to be
basically the scenario is I'm trying to transfer money to someone.
Yeah, you're trying to transfer money to someone, and then you have a community of strangers across the world creating the payment rails for everything. They're supporting all the activity that transaction incurs seamlessly, all within inside of half a second. I feel like you would think it's sci-fi or something, really, because of the whole. Why are there strangers supporting this network? What's their incentive, and then how is that faster, better, et cetera, than what we have now? And to be honest, the only thing that's really allowed this to be so successful is how strong our hardware has gotten over time. Back in 2009, our phones were, abysmal compared to today. This idea of having a distributed computing platform where there's all these different computers across the world contributing, it's because the cost of that hardware is so small now. Only Amazon back in the day, or a company similar, could afford that structure. They got to raise money, or they got to put 10 million into supporting 100,000 users, let's say.
Yeah.
But now, one of the most sophisticated computers we have are in our pockets everywhere. The chips and the storage and everything else in those phones are way cheaper.
And everybody brings their own hardware to the
Exactly.
game, and yeah, interesting how it changes the cost structure. But so back to, I'm trying to transfer money. I use Venmo. It appears to me to be safe. I've never had a problem that I'm aware of. Why leave this to strangers all around the world to help me transfer this money? What makes that safer? What makes that faster?
Well, you don't mind using Venmo in that comparative analysis because you're in good standing with Mr. Bezos, right? Or whoever owns PayPal, actually. Because PayPal owns Venmo. But either way, my point is, it's fine and good until you violate a term of service, or they seize your account because you transferred too much money to your wife, and they think it's a taxable event, or uh, a multitude of other things that could disparage your situation that you're trying to pay for. I feel like that's happened to me. At least I have a power washing business, and PayPal, this is a problem I've just been dealing with. They withhold deposits without your consent. You agree to this in the terms of service. They withhold the deposits for um, a very inconvenient period of time that has no end date, because they want to protect the customer from refunds and things like that. Some form of redemptive ability. But to the business owner, I've had to take short loans or just contribute more of my capital waiting for that money to clear. And it's a super inconvenient thing, and it feels close to, a dictatorship or communism.
So it almost sounds like, on the distributed network, doing this transaction, it's just, there's really not a centralized body controlling it, policing it. But, back to, is it safer? Is it faster? What are the advantages of,
Security, yeah, safety. So not only do you have that liberty in this network, but also in computer science, where the majority of vulnerabilities exist. So like how hacks occur and things like that. It's in the transmission of messaging between computers. So in that monolithic structure, when I put buy, let's say I place my order, and there's that lag for that order to go through. What's happening on a technical level is you built out an order that is just a file that then gets sent to a server. In that transmission period, there is no protection. I mean, you're just sending it right there. And if someone was able to get in front of the API that stands in front of the computer, so if they were to just intersect it, right, get right in front of it, they would be able to extract all of that
what is
information.
Sorry.
It's an application programming interface.
Okay.
That's what the acronym stands for, but it's basically just a bucket of code. We could think of it as a bucket of code that is traffic cop to messages between systems, let's say. This goes here, this goes there.
Yeah.
Things like that. And they're always stood up in between computers in a monolithic structure, because one server could be handling, let's say, 10,000 files at a time, right? So it needs to know which server goes where, and it's just a way to optimize storage and things like that.
Right.
So in a distributed computing platform, it's very interesting, like a blockchain specifically. That's what we're talking about here. A block is a period of time where that transmission is allowed. Um, the time that that block is open is called a time to finality. When that block closes, it is 128-bit encrypted. So in a monolithic structure, the website sends a message to the server. In this distributed platform or blockchain, you have the same exact thing. Let's say I'm just sending money to you, and all that activity and just our transaction, but literally every transaction on the network inside of this block time, and that's running 24/7, 365. Every 15 seconds, a Bitcoin block is open. Then there's an order of transactions inside of those 15 seconds, and then our transaction enters a queue, and then all of those computers work together to work through those transactions submitted in that block after the block is closed. And then once those transactions are completed, they get posted onto a ledger. That's the next part of the blockchain to understand. And we'll get into that in a second. So the real difference is in those 15 seconds, it's vulnerable. But after that, it is encrypted till the ends of time. And as long as that network is still functional, it cannot be messed with. It's immutable. It is not, you cannot play with it. So the transmission is completely secure. And the only way to attack a block is to have 51% of the computers of that network in that time to finality, which is like a lot of computers. You know?
I mean, how many? I'm sure it depends on the
Yeah, I mean,
what blockchain, but
that's the cool thing about these, these platforms. They, the more computers, the more secure, the faster. And that's why since the beginning of time, distributed computing has always theoretically been better. The more nodes you have on a network, the more secure it becomes and the more valuable it
so
becomes.
is there something different than back to like the Venmo, because I could log in and I could see my history,
Mhm.
a ledger of some sort, my mind.
Correct. Yeah.
I certainly can't see anybody else's transactions,
Nor can they see yours.
nor could they see mine. But in this distributed network and on the blockchain, that I think correct is open for everybody to see and go back, and so there's a
Yeah.
real record, a real transparency.
And it's anonymous. A lot of people might be
Yeah,
scared by
yeah,
that.
it is anonymous because nobody would want the entire world to see what we're buying, what we're looking at.
Amen. Who does?
Right.
You're anonymized by your wallet ID.
Mm-hmm. That's
So
just a number.
it's just a random string of text and numbers. So like AB06X5C3, I mean, that doesn't mean anything.
Yeah.
Then that wallet logs every single transaction that it ever does on that network.
Mm-hmm.
And that is available to anyone with an internet connection. The benefits of that, it goes back to these bad actors. If that wallet does anything that is scrupulous at all, we all know instantly. It brings a next level of transparency that is profound in our world. You can look at FTX, for example.
Who decides if somebody's a bad actor?
Basically in Bitcoin, since we're going to stick to this example, the only bad act you can commit is approving a false transaction or a transaction that is, it doesn't meet the criterion of what a transaction would be. And you would need 51% of the network. The scariest part about Bitcoin, really.
I'm not quite grasping that. So,
Okay.
I'm kind of back to what, I'm trying to do a transaction. Let's say that I want to use some Bitcoin to buy something. Okay. I'm going to click the buttons on the computer, pay with my Bitcoin. So I'm starting a transaction.
Yep.
Right. Who, like if I'm buying something illegal, does that make me a bad actor? Are we talking about?
I see.
Or, because I certainly don't have the ability to,
Right. A bad actor, that's a great, so just to interject there, I mean, let's say that the spot price of Bitcoin at the time of this recording is like 28.8K.
Mhm.
A bad transaction would be me buying 10 Bitcoin for it today, right now.
Yeah.
Great for me if I could figure that out, right? Or reward myself 50 Bitcoin for one block, which is, probably 1 millionth times what the reward is right now, right? So not you and I or anyone else could do something like that because we would need billions of dollars of computers to allow for that to happen. 51% of the entire network. The biggest vulnerability of Bitcoin really is if all these big mining companies got together, they could do that stuff if they all weren't being enforced by antitrust law and things like that, right? But if they were to pool all of the miners they owned, and it was, I think it would be, I don't even know, probably, yeah, 51% of 400 billion market cap. I mean, that's a lot of computers, right? So, I mean, we could not do any of that. Our transactions are not even 0.00000 whatever percent of the network. So, I mean, that it does not apply to people like us.
So bad actor isn't somebody, who, you hear a lot, you hear a lot of people in Congress saying, well, crypto is going to cause, an easier way for criminals to, conduct their business and acquire things. We're not talking as far as bad actors of the actions that people are taking or going to do with, the money, where we're talking more preventing a fraudulent transaction, it sounds like.
Yeah.
So with the transparency of the blockchain and, I want to execute this transaction, it has to be proved, by millions or hundreds of thousands of computers, which, once they come to consensus and you're relying on, the fact that you're not going to have that many people make a mistake or overlook something and allow some kind of fraudulent transaction, acquiring 10 Bitcoin for $1.
Exactly. Yeah. Bad actors in crypto were referring to computer science in general. Like you got to remember, there's all this crypto bros and all this media and all this other stuff, but really this is fundamentally computer science. We're building the equivalent of rocket ships here, blockchains that are worth trillions of dollars in the future, most likely. Well, it's worth a trillion today if you look at the entire space. And then the last piece to understand of a blockchain, we've covered encryption or security. We've covered the difference between network structures and why it's better. But finally, we have consensus in that, and that's really the last kind of pillar of blockchain. What makes it so powerful is in a monolithic structure. We go back to that Venmo example, and this or the PayPal example even that I've dealt with, right? I consented to using PayPal to accept customer payments, and there's those transactions. They seem fast, they're seamless, etc. You have that social issue where the company doesn't like the way we're doing things, and they hold all of our money. It costs us a lot of pain. But also for those transactions to go through, the consensus of that system or the agreeing of, yeah, that's a credible transaction. It is very simple. It is vendor, customer, vendor puts in the amount owed, customer meets the amount, transaction goes through, they take their 2% for reaching consensus. 2% for reaching consensus and securing the
This is
payment.
in PayPal.
That's PayPal. That's Web 2.0. That's how it works, right? Sometimes 3% plus your credit card fee. I'm out 5% if you use Amex. 5%, right? That's a lot. Especially if you're talking about $1,000, $10,000, $100,000 a month, let's say, in a business. It's a lot of money.
Sure.
In Web3 or blockchain, these distributed, platforms here, or networks, consensus is reached by a set number of computers. So those miners, in Bitcoin specifically, they use a consensus method called proof of work. It's old and outdated, but it is very effective. You can participate in the network, as you and I have, as people that just buy the token. But you could also be a miner. And what miners do is they have computers plugged into the wall. Those are called ASICs. They're graphic processing units, or GPUs. Same thing you use for your computer, probably what's in your phone listening to the cast now, right? Those GPUs are built to just solve really difficult math problems or cryptographic problems.
Mhm.
Cryptography is why this space is called crypto. It is the root of blockchain. So these miners go in that block, that 15-second block, they have to solve, like they meaning a bunch of different computers. They get randomly selected to solve the cryptography as the blocks closed to approve those transactions. And if they all come to the same consensus, they all say, yep, that amount of Bitcoin's correct, the price is correct, that wallet's correct. They have a bunch of these different points. They all come to a conclusion that's a proper transaction. It's closed in the block, and then it's published on the chain. Now, the reason why we call it real quick in the blockchain, once consensus is met, the previous 15-second block is already closed. There's a block ID in that block, right? It's a block number. Every block is published, and we know every block number. The next block only exists because of the previous block. And that's why it's a chain. So block open, close, block open, close. And then over time, you can envision just these blocks turning into a big chain of random transactions, but they're all encrypted blocks. The consensus mechanism is infinitely more scalable. The more nodes on the network makes it more secure because
Sorry, node.
node is the computer,
Yes.
the participant in that network. That's another word for a participating computer, it'd be a node. As the network gets more nodes, the randomness, that's what makes software more secure. The more random something is selected or chosen, it makes it more secure, harder to predict for the bad actors, right? So the more nodes, the more random, the more random selection of nodes that actually reach consensus and so on. So the network gets stronger and better the more people that play in it. And that is what makes blockchain that profound. It's this exponential growth curve. The more nodes makes it more secure, makes it more valuable, the more nodes, and then it keeps growing.
And I presume there's nobody taking a 2 to 5% fee.
Thank you for bringing that back up. Yeah, that was a great point. Yeah, Bitcoin will charge you, and it's slow and expensive. If you think about it, we could get into so many different projects that are cheaper, better, et cetera. But Bitcoin at most will take 0.01%, 0.02% in fees to pay the miners for reaching that consensus. Significantly cheaper than what we're used to now.
So if we look at PayPal, when we compare that to some kind of blockchain application that serves a similar function, we feel that it's more secure,
It is.
more efficient,
It is.
and cheaper.
Yeah.
You're knocking out the middleman.
Exactly. We're knocking out the middleman. We're not being governed by some large company that has problems with how we want to use the software, how we want to live our life. We have more liberty and we spend less money using it. And we're also supporting other, inhabitants of this earth. The money's going to another human, usually, who could use the money most likely, or will contribute to the economy in some way versus just lining, the wealthiest of the wealthy's pockets and growing their business for them. They've solved all of our problems, but they've taken quite the sizable cut from our efforts. And it's, we only see those central tensions growing over time. We see these issues becoming more pressing than they were 10 years ago. And that is a trend that blockchain is going to be the answer.
And is blockchain, would it be accurate to say that is absolutely one of the fundamental principles of all what will be Web3?
Yeah. I think I'm very confident that 10, 15 years from now, on-chain, online, the way we used to say online, for example, like on-line, and then people would mess it up, not understanding what online was. That's how on-chain will become. Everything in the future will be on-chain because for the reasons we've discussed in this episode, on-chain is a lot better than online.
But there are many chains, correct? It's not just one chain that all of these different Web3 projects and assets access, they might have their own.
Absolutely.
So there's different speeds with which transactions can be done, and that's, where you talk about all the exciting things.
Yes.
Other, I always say companies, but
We'll break down that down. Yeah. Absolutely. Yeah. There's an infinite amount that could be generated. All these blockchains are public. So if I was a really smart, motivated developer, I could, we can make an episode about this, but, we can fork a chain, which just means copy it. Dogecoin is a copy of Bitcoin. A lot of people don't know that. It's just a fork. We picked a block number, or some developer picked a block number, literally copy pasted Bitcoin's code, called it Dogecoin, took a picture of a Courtney, put it in on the website in the white paper, called it a meme, and it's now worth $20 billion, and it's just a copy of Bitcoin.
A lot to unpack there. It's a couple sentences.
Yeah, there's a lot. We'd love to probably save that for another episode.
Sure.
Well, the one thing we just want to understand, a blockchain is the next iteration of the internet. It is better than, traditional networks that we're used to in Web 2. And there is an infinite amount that could be created, infinite. And the more participants you have on a blockchain, the more valuable and secure and better it becomes over time.
So as I hear it, on kind of Web 2, I'm logging into monolithic structures, accounts. It's out of my control. My, user history, all of that is owned by some company, some other centralized structure. And, there's things that are hacked, sometimes information is leaked, you've got these problems. It can be expensive. We use credit cards, we use things like PayPal. Web3 going on chain, we're getting away from this monolithic structure to distributed network. We've got millions of people working together. The transactions are coming in. We feel secure because we've got so many people, so many nodes, I think, that are computing and saying, yes, this transaction is correct. There's no middleman. It's less expensive. It's private. Yet there's accountability because even though it's private and anonymous, we forever lock this into the chain and can go back and see that. We don't worry about data being deleted, after 6 months. I mean, it's there.
You're killing me. I feel like we can switch roles now. I feel like you learned.
I don't know about that.
No, it's perfect. Yeah, absolutely. Those are the core tenets of blockchain.
Okay.
You got a good grasp.
Yeah. So aside from financial transactions, I mean, is there any quick hits you can provide on why blockchain is cool and, what it might do for, I know everything's somewhat, there's financial components, to it, but, we've really only talked about transactions and
Correct. Yeah.
Conducting business. Is there other benefits? I mean, is there,
Yeah, certainly.
Does it help game? Does it help?
I'm going to take it to that fundamental level again. When we talk about the internet of value and exchanging value, most people think of dollars, right? That's what we've been talking about the past 30, 40 minutes is dollars. But it could also be just valuable information, for example, a vote. Like right now, there's a monolithic structure for voting. I got to go in to a ballot box. It's all owned by the government, et cetera. And then I have to physically drive there and all this other stuff, where in blockchain, since it's encrypted and I have this wallet ID, let's say in the future, we know that there's at least one wallet that the government gives us, and that's tied to our identity. So it's invaluable. You cannot deny that my federally issued wallet, no different than my social security number, that is me, right?
So if somebody shows up with a wallet, that's their social security number, that's their,
Right now, they show up with a physical wallet,
yeah,
and they show their ID,
yeah.
right? I'm saying in the future, you wouldn't have to drive anywhere. A transaction on blockchain could be you submitting a vote for a candidate that's
What,
tied.
what if I had your wallet and I vote as you?
You would need to know my seed phrase, and you would need to, be able to take all of my crypto in addition to cast a vote. So we're talking about a serious offense, or you just being completely
We're talking about theft of password.
correct.
More or
Yeah,
less.
no different than someone stealing your identity and putting in a vote now. Those consequences exist
So
today.
it's hard to steal the password.
Oh, absolutely, yeah. You'd have to stumble upon someone that wrote it down, or you'd have to hold them at gunpoint and get it from them, or something very nefarious to access.
I mean, I think of my father, God bless him, he calls me once a week, trying to get password help and can't log into this, or, something's gone awry. I couldn't even imagine him, tasked with the responsibility of,
Yeah,
keeping his password straight, but perhaps, is that where we might see, what sometimes you call layer two, some technology that comes about that'll probably help people with that kind of management of the password and security.
yeah. Key management is definitely going to be one of the things that needs work, and we need better solutions for this to be massively adopted. Because I totally agree. There's just going to be a segment of the population that has no hope of properly managing their keys or passwords for blockchain.
Yeah.
But in this example, just submitting a vote, that is valuable. That could be on the chain. It could be distributed, no different, because it's on chain than a financial transaction. And that would be an exchange of value between a constituent and their state nation. So there's a lot of different things that are valuable that, if on chain, could make our lives a lot more convenient and more secure in general. So with that, we thank you guys for tuning in. Hopefully you learned something and you can talk about some of the fundamental exciting things regarding blockchain, just like Steve did. And we thank you for coming in and listening.
Thank you. We'll see you next time.